Good morning, students. So yesterday I discussed about the acids and hope you all have understood the concept what I have given you for acids. What are acids? Its physical properties like turns blue litmus to red, conducts electricity, sour in taste, and coming to the chemical properties, when it reacts, acids when reacts with base, it forms salt and water, which we call it as the neutralization reaction. And when it reacts metals, it reacts with metals, it forms metal salt and liberating hydrogen gas, that you can check by the pop sound. With metal carbonates or bicarbonates, it gives carbon dioxide gas, and with metal oxide, it forms metal salt and water. Then I discussed about the strong acids and weak acids, which dissociate completely in water. They are called strong acids, which do not dissociate completely. Mainly organic acids are strong acids, and inorganic acids are strong acids, and organic acids are weak acids. Then I gave you Arrhenius concept, then correct way of diluting the acids, and then like compounds like glucose and alcohol, since they do not dissociate hydrogen ion, so do not conduct electricity, whereas acids, they conduct electricity. Now, and then after one more thing I discussed about the indicators, or natural and artificial, as well as the olfactory indicators like raw onion and vanilla essence. Today I will be discussing you, so hope you are now ready with your copies and books. I will be discussing about bases. So what are bases? First let me tell you about the physical properties. So bases are those substances which are bitter in taste. First, bitter in taste. Second, turns red litmus to blue, and blue remains blue, no change. Okay. Then it also conducts electricity. Third, changes the indicator of methyl orange to yellow. When you take a base, suppose you take a base and you add methyl orange to it, you will see the methyl orange color change, the color changes to yellow. And one more thing, phenolphthalein, that is colorless phenolphthalein indicator. It is a colorless solution. When you add to the base, it forms what? It changes to pink color. Now some common bases are like NaOH. This you call it as caustic soda or sodium hydroxide. KOH you call caustic potash. This is all are strong base. These are strong base. And if you take about one more, calcium hydroxide is there, that is also a strong base. Now if you come about like ammonium hydroxide, NH4OH, or sodium carbonate, these are all weak base. Fine. The chemical properties. First, chemical properties. When sodium base reacts with metal, give metallic salt and liberate hydrogen gas. And if I take NaOH plus zinc, it forms Na2ZnO2 plus H2. This you call it as sodium zincate. Instead of sodium hydroxide, you can take aluminum hydroxide also. You can take, in case of zinc, you can take aluminum also and do the same reaction, like 2Al plus 2NaOH plus H2O. It forms 2NaAlO2 plus H2. Fine. It forms H2. 2NaLO2 plus 3H2O2. Next one, this is first property. Second is the same reaction with base plus acid gives salt plus water. Like NaOH plus H2SO4, suppose it will form Na2SO4 plus water. This is base and this is acid. It will form metal salt and water. Now next is reaction of base with non-metallic oxide. Reaction of base with non-metallic oxide. Like if you take sodium hydroxide, 2NaOH plus CO2. This is carbon dioxide, is a non-metallic oxide. What does it do? When it comes in contact with water, it forms what? It forms sodium carbonate and releases water. Okay. Carbonic non-metallic oxides are acidic in nature. That is, when it reacts with water, it forms acids. Na2CO3 plus H2O. Fine. Now, bases when dissolved in water. When you dissolve base in water, NaOH, when you dissolve in water, it will form strong base plus hydroxyl. This OH you call it as hydroxyl ion. You call it as hydroxyl ion. Fine. But these are strong base. This is a strong base. This is a strong base. But if you take ammonium hydroxide, this is ammonium hydroxide. It is reversible. It forms NH. That means complete dissociation does not take place. Is it, students? No. One more thing is there. Some bases are known as alkalis. You may have come to these terms. Alkalis. What are alkalis? Water soluble bases. Water soluble bases are called alkalis, like NaOH, KOH, etc. These are water soluble bases. Bases which are soluble in water, they are called as alkalis. Okay. And so we can say, I am giving you a question, like all alkalis are bases, but all bases are not alkalis. Why? Because alkalis are first of all bases, but those bases which are soluble in water. But there are some bases which may or may not be soluble in water. So you cannot say all bases are alkalis. So all alkalis are bases. All alkalis are bases, but all bases are not alkalis. This question. So now there are some uses of bases, like base like sodium hydroxide, it is used for soap manufacturing or laboratory reagent. KOH is used in alkaline batteries, and calcium hydroxide is used for bleaching powder. Now applications of neutralization reaction. Now person who are suffering from acidity, sometimes if you eat too tasty food or too much of food, you feel acid. Okay, so people suffering from acidity are given antacid tablets like magnesium hydroxide. Magnesium hydroxide acts as an antacid. Antacid to neutralize the acid present in the stomach. Okay. Now sting of bees and ants, which contains formic acid. Sting of bees and ants. When they stick it, it's very painful. It releases formic acid. FOR, formic acid. To neutralize this acid, you rub that place with sodium bicarbonate, mild base like sodium bicarbonate or sodium bicarbonate. Okay. If the soil, if it's too acidic, if the soil is very acidic or too acidic, farmers they apply calcium hydroxide, slaked lime, as a base to neutralize that acid, and the crops will grow in a proper manner. And the one more important is that, for making cake we use baking soda. Okay, we use baking soda. Now this baking soda, if you add to the cake will not be, it will give an alkaline, it will taste bitter in taste. So to that cake, this is NaHCO3, this is baking soda. Baking soda. To this, if you add small amount of tartaric acid, tartaric acid, to neutralize this alkalinity, the cake will rise up and fluffy. It will become fluffy. This is called baking powder. This we call it as baking powder, my dear students. Fine. Now, so this is all about the bases. Now, what are monobasic acid, dibasic acid, tribasic acid? The number of replaceable hydrogen in the acid is called basicity of an acid. Suppose HCl, it has one replaceable hydrogen, so it is monobasic 1. H2SO4, it is dibasic. Dibasic, it has 2 replaceable hydrogen. And H3O PO4, phosphoric acid, it is tribasic. It has got 3 replaceable hydrogen ions. So this is about the. Now my dear students, almost I have tried to complete the topics of acids and base. I will provide you the notes along with the videos. Please, my dear students, go through the videos and the notes. If you find any sorts of difficulty in understanding anywhere, please feel free to contact me. Don't hesitate. Thinking that what's up, any doubts, you feel free, because I have tried my level best to collect notes from 2-3 books and give it to you. And if you note down this will be more than sufficient for your exams. Hope you will complete the work on time and submit your copies when the school opens. And hope for your cooperation. And I know you all are very eager to meet each other. We are also eager to meet you when the school opens. But then till then, whatever available things are there, from that we are trying to teach you the best and give you notes. And please note down the copies, everything what I have given you. Thank you very much. Have a nice day.